We're being asked to write f of x in partial fractions in this question. Now notice we've got 1 plus 3x squared. That doesn't factorize nicely into real linear factors. We have to leave it as such, which means we get this here. Now if you've done further maths, you might be familiar with dealing with terms like this. If not, it might be new to you, but we can, so the challenge will be to deal with this unknown scenario, but we can still follow the same steps. We're just going to need to be a bit more careful, as we'll see in due course. So first things first, going to set them, just going to write it all down, set them equal to one another. So 1 minus 3x, 1 plus 3x squared. Okay, this can be equivalent to that. Now we can multiply through by the denominator. Notice we have 4 coefficients to find. Okay, that's our identity that we need to deal with. Now, it's worth just talking about 2 main methods for dealing with this. One is to substitute x values in, and one is to compare coefficients. Now, I always think it's a good idea to substitute in as much as you can. It's just a slightly simpler method. So first of all, I'm going to let x equal 1. That's the natural thing to try because these 2 terms will completely cancel and I'll be able to work out what d is. So we're going to get minus 2, the left-hand side, is equal to 1 plus 3, lots of d, so 4d, and therefore d is equal to minus a half. There's no other obvious one to do to cancel terms out. A good shout in these situations is to try x equals 0. We could avoid doing that by, we could compare coefficients, but actually the way we're going to do it, we'll see this is the quickest approach. So x equals 0, we're going to get 1 is equal to b, because this is just 0, this is just 0, so it's just b times 1 squared. Over here, it's just going to be plus c plus d. And therefore, we can actually, this is minus a half, so we're going to get b plus c is equal to 3 over 2. Now actually, what we've just done is the same as if we had compared the coefficients of the constants, actually. So that is the same as, or x to the 0, we're just literally looking at, because it's an identity, that must be, it must be that they're always the same. But we've got d is minus a half, we've got relationship between b and c, we've got to keep going now. So let's compare coefficients. Now the highest power is x to the 3. So I'm going to compare the coefficients of x to the 3. On the left-hand side, there's no terms in x to the 3, so that's going to be 0. And here, I'm going to get an x squared. Like, you could multiply the whole thing out, but it's just whether we can do it without having to multiply the whole thing out. I'm going to get an x squared term times ax. That's going to give me ax cubed, so I'm going to get a term in x cubed. And over here, I'm going to get c times 3x squared times minus x. That's going to be how I can get a cubic term. So it's going to be minus 3c. And we've got another equation to deal with. That just leaves either comparing the coefficients of x or x squared, and it's up to you which you go with. I don't think one is particularly nicer than the other. Let's look at x. So the coefficients of x. On the left-hand side, I'm just going to have minus 3. Right, now we need to think about this carefully. I'm going to get it equal to a, because I've got ax, when I times that ax by 1, I'll keep ax, so a is my coefficient. And then for the b, I'm going to get 1 minus 2x plus x squared, so it's going to be minus 2b. Over here, the only way I can get it is by doing 1 times minus x, because all the other terms will be different, so I'm going to get minus c. And there's no contribution from d over here. All right, is that enough to be able to deal with this, is the question. And I think it will be, because we've got that a is equal to 3c. So I can substitute in minus 3 is going to equal 3c minus c, that's 2c minus 2b. And I've also got that 2b plus 2c is equal to 3. So I can add these two together. I'm just going to write them out again. 2b plus 2c is equal to 3. And minus 2b plus 2c is equal to minus 3. So if I add these together, I'm going to get that 4c is actually equal to 0. And therefore c is 0. And that's I probably should start drawing boxes around these. It just happens in this scenario that there is no term in 1 minus x. We'd normally expect one in general, but yeah, there will be cases where it's 0. Okay, if c is 0, then hey, that actually is nice because it means a is 0 as well. Because a is 3c. And then finally, that just, therefore, we're left with the 2b is equal to 3. b, it's going to be 3 over 2. So we found the constants. It's up to you if you, at this point, want to write down the function. I think I'm going to. We've managed to write it in partial fractions. So we've got ax plus b. b was 3 over 2, so 1 plus 3x squared. Yeah, you can have the fraction in the numerator, or you can move that 2 down. Then we had the c term was 0, and then d was minus a half, so minus 1 over 2, 1 minus x all squared. That was the most time-consuming part of the question, I think, but absolutely critical for the next part. Because it says, find a series expansion for f of x in ascending powers of x up to and including x to the 4. Now, we don't want to use this original function. You're going to have to deal with an expansion for this, and then multiply by 1 minus 3x. You could do it that way, and feel free. But it's this is 4 marks. This shouldn't take that long. And what we can do is take our f of x that we've just found, and then we're just going to have to be subtracting the 2. So f of x is going to be 3 over 2, 1 plus 3x squared to the minus 1, minus a half, 1 minus x to the minus 2. So let's just remind ourselves, we've got that 1 plus x to the n is 1 plus nx plus n minus 1 over 2 factorial x squared, and then you just keep kind of following this pattern. It's not too bad to remember this. Therefore, 1 plus 3x squared to the minus 1 Okay, I'm dealing with it exactly the same. I replace all my x's by 3x squared though in this case. sorry, 3x squared squared this bit is. I'm just struggling to fit it in. Okay, and actually, because I only want to go up to x to the 4, that's all I need, the first 3 terms. Here I've got a double negative, so it's going to be 2. That's going to cancel out, so I'm going to get plus 9x to the 4. Nice one. Okay, just be careful with all the negatives going on here. Double negative, so 1 plus 2x. Double negative again, and then this one's positive. So that's going to give us 3. This cancels with this. 4. And this one's going to be 5. That is going to cancel with that and that negative. So we're left with f of x is 3 over 2 lots of this. And then we're minusing a half of the rest. Okay, minus a half times 2x, just minus x. So these become 1. Oh wait, sorry, jumped into this a bit, so it's just a minus x term by itself here. I'm just crossing them off to know I've dealt with them. This is going to leave me minus 12 over 2x squared, so minus 6x squared. And then plus 22x to the 4. So 22 over 2x to the 4. That is our final answer. Okay, it's quite nice how all the fractions disappeared at the end. So that is our series expansion of the original function here. And remember, it will, for small values of x, be a very good approximation. The very last question is a pretty neat question, I think. So find an equation of the tangent to the curve with y equals f of x at the point where x is equal to 0. The first thing to say is that f of 0 is going to be 1 over 1 is just going to be 1. So when x is 0, y is 1. We just now need the gradients. Now you could try and differentiate this, but we have a series expansion, which is obviously it's actually an infinite series, but at the special point when x is 0, well, all the other terms are going to be 0. So this is not this is f of x though. So we need to find out what df by dx is, and that is going to be minus 1 minus 12x minus 6x squared plus 44x to the 3, etc. When x is equal to 0, df by dx is equal to minus 1. Not even approximate. This is exact. So we can use y minus y1. We've got the point that goes through when x is 0, goes through y equals 1. We've got the gradient. So this is actually really quick. Just have to recognize to use this expansion. It's really neat. So y minus 1 is going to be minus x minus 0. I don't even need to write that in. So y is going to be minus x plus 1. That is the equation of our tangent. Really nice answer to this question. Good question.